Hello, everyone. Welcome to another session here with PaaS Virtual Summit. Uh, this is the Migrating Oracle Workloads to Azure. What you really need to know. I know all of you were like, I didn't need to know another database platform, but here it is. If you have not seen this slide already, this gives you the opportunity to look into everything with PaaS. As most of you know, I'm from the Oracle world. I will tell you, don't get a lot free over there. And there is tons of things to get connected with PaaS, a lot of virtual groups. Of course, your SQL Saturdays that may be virtual now, but hopefully won't be forever, that you can get involved in the PaaS marathons. These are tons of content that people are willing to share their knowledge with you. Take advantage of that. It is a wonderful thing and it helps advance your career and your knowledge. If you have not started doing this for any of the sessions you've submitted, definitely fill out your session evaluations. I would greatly appreciate it if you did it for mine as well. This is another, of course, all this is new content, but another new session for myself that I'm very interested in seeing some feedback from. And of course, they're giving away prizes too. So how can you beat out on that? Get some goodies. If you're not familiar with who I am, my name is Kellyn van Gorman, also Kellyn Gorman. I can be found on all those lovely little links on the left-hand side there. And if you follow me on Twitter, as I always do, I apologize. I know I'm noisy. I've been a multi-platform DBA for about 22 years now. I'm also a DevOps engineer. I believe that anything that's worth doing twice is worth automating. So I automate it all. And yeah, I do it in Bash, even on Azure, but I love doing anything, making it easier to do and doing, I guess, more with less. I've lived and worked from an RV with my husband for the last 2.5 years. We're hopefully going to move into our floating home soon. I was hoping I was going to do this session from the floating home, but as you can see, that the huge fridge and behind me, I'm still in the RV. So you're getting a session from somebody who lives and works in an RV right now. And my husband also, he works with me not only at Microsoft, he works on the same team doing the same thing with me. So when you start talking Oracle on Azure, you pretty much get the Gorman team. It's going to be one or the other of us. So what are we going to cover today? We're going to kind of talk about Oracle on Azure. I know it's a data unicorn, it happens. We're going to talk about how we move these workloads. Infrastructure as a service, which is kind of the thing to do with this. You're maybe hearing some different things from marketing, but we're going to talk to you about the reality and what we do with this. We're going to talk about the performance implications of going Oracle on Azure and how to deal with those. We're going to talk about the tools, the tips, the tricks, migration tools, things like that, and then how to do it in a way that makes sense and hopefully share with you the tips and tricks that we have learned doing this day in and day out. So Oracle in the Microsoft world, no matter how much we want to admit it, Oracle is a huge percentage of the database workloads, those RDBMSs. We're seeing it at least 30% of those relational databases that are out there. We feel the pressure and the pain point of it. I have always been multi-platform. I'm one of those that took my Oracle certification, came into my first job, and they handed me this monstrous SQL Server 7 and said, here you go, here's your database. And Oracle came right after that, but yeah, I've always done both. But we recognize that Oracle is part of this larger data estate. As anybody's saying, hey, I just do Oracle or I just do SQL Server, most of you really don't. You have at least one database on another platform. You may have a couple of them. And because it's a database, your bosses expect you to manage it. So now that you're moving to the cloud, you're trying to figure out, what am I really going to be faced with? And as you can see on here, I think this is another good, the first one was DB Engines, if you're wondering where that came from, dbengines.org. This one, of course, comes from Gartner. And this is the magic quadrant of database systems, from Gartner. And make sure that everybody can see my slides still. Let me know. Okay, my screen share just went down and I was worried about it. But you can still see my presentation? Okay. Yep, for some reason, everything went down. So give me a second and we'll just pick up from here. Is it sharing right now? Okay, give me a second. We are having technical difficulties. You should be seeing a nice, beautiful floral background right now. Is that good? Okay, and let me bring up my slides again. And we should be back in business. Yay, thank you. Thank you for the support from those behind the scenes, the man behind the curtain. So as we were saying, with these databases, you're seeing, of course, a number of ones. When we talk about AWS, of course, we're talking about PostgreSQL and MySQL behind there, but we're all learning a lot of new stuff right now. For my Microsoft folks, Oracle is often seen as this anchor. It's holding them back from getting to the cloud, or it's going to a different cloud and they're not sure what they're going to deal with. I have one customer that is moving their Oracle databases onto Azure at the same time. They've got some Oracle databases sitting on Oracle Cloud. They've got some running on GCP that's actually a terabyte data system. And they've got 7 terabytes of data loads that they need to master every single day. It is quite a challenge. And we don't want to do that. We're finding that single cloud solutions a lot of times gives you the best benefit. And so if you've got multi-platform environments that you can bring to one cloud, that's very powerful. Our other challenges, of course, with Oracle is that story of rack, real application clusters, which we'll talk a little bit more about, but that it's not supported in any third-party cloud. So how do you bring those from a real application cluster into a single instance and make sure you get the performance that you need, that you have your high availability, that you have your DR solutions, because people will confuse it with all of that. All these archaic databases. I think I'm being told that I'm not allowed to share my screen and use too, so we're not going to do this. Obviously, my screen share is stopped. I'm not sure exactly what's going on, but we'll just take that as a hint. That looks good. Apologies for the frustration here. We're good? Okay. I'm going to stay right with this and we're good. I just unplugged my other monitor, so let's make sure this stays and keeps going. With these archaic systems, of course, you have all this data that you'd like to do more with. You don't want to just load it into like a cloud that doesn't have other options such as machine learning and AI and has the ability to build out these data lakes and to do more with what you've got. So these are some of those challenges that customers are facing, as well as multi-tier systems. They can't be migrated off of Oracle. We start talking about the dependencies, PL/SQL functions. PL/SQL makes the Oracle world go round. You can't just change that over to T-SQL a lot of times. There's window functions, very cool, but some of these PL/SQL functions are very advanced. Being able to refactor all of that is a lot of work. I mean, a lot of work, years in the making. So that may be an issue. Other things is vendor lock-in. They may say, I only run on Oracle. My application only connect on Oracle. My application is an Oracle product. So how do we Azure it? You're going to hear that, for Oracle, when you come to Microsoft, oh, we'll put it on PostgreSQL or put it on Cosmos DB or Azure Synapse. Those only cover about 10 to 20% of the cases. Most of the work is actually done by people like myself doing infrastructure as a service. PostgreSQL is fantastic for new projects. Instead of, paying for an Oracle license, go PostgreSQL, awesome. Cosmos DB might take some of that JSON documents and some other stuff that went into Oracle that probably should have been in a document database to begin with, go that direction. Azure Synapse, some of the workloads that we've got for analytics sitting in Exadata, another reason, go there. Can you take an Exadata and lift and shift it and put it into Azure Synapse, refactor it into these other things? Probably not. We have over 1,700 customers that are running infrastructure as a service with Oracle and Azure, and they're very, very happy, and we like that. So lift and shift is really more of the, the reality. It's not the outlier. It's not that this doesn't happen much. We've got the customers to prove that. So let's talk about what this looks like and having some background. If you're not as familiar with Oracle of how to translate this information, this is exactly what we're looking at here. I use this diagram very often, and you can find this. If you don't find it in the slides, I've got a link to my blog post down here that'll take you to this. The way that this is built out is that sometimes you will find with Oracle versus SQL Server that there are terms that are being utilized more than once between these two platforms. They don't mean the same thing. So we'll start with instance. On the left-hand side, look inside that green box. That is the term instance in SQL Server or on Oracle. And then if you look on the right-hand side, you'll see instance in SQL Server. It's really just the software installation. Oracle, it's a lot more. It is the background processes. It is our memory. It is all of that that's running in memory. And we need to keep that in mind. I mean, that's all of those pieces. We call our software installation our Oracle Home. You'll hear us refer to the Oracle Home, which you would call the instance. We start talking about the database. Database is pretty much everything on the SQL Server side versus the database inside of Oracle is just what consists of really the data files. Those data files, control files, redo log files, the, SP file, parameter file, which really consists of what you would call your SP configure. And then our password file, which is a secure area and encoded file that keeps our password information, tells us a little bit of information about that password. We also have something called the process global area, which is outside our main memory. That's doing a lot of stuff about processing, sorting, hashing, some of our PL SQL tables. All that is being processed in there. That is completely separate from our actual memory that's being used for our main part of our database. But does SQL Server need this? No, it doesn't need it a lot because it does have the ability to have sorted indexes. Those indexes, those clustered indexes, is something more foreign to the Oracle world. We have something called index organized tables, but they have a very small use case. So you're not going to see them very often. So these are kind of those features that we talk about. And I do have a reference here, so you can kind of keep this in mind. Oracle instance, what does it mean? DB server, Oracle home, server instance, how these actually relate to this. We'll talk about the automatic workload repository because we rely on that a lot for our inside information. It's kind of the same as the query store and the DMVs all put together inside a repository with an 8 days retention by default, 1 hour snapshots, always on, and it's collecting information all the time. And I'll go into this a little bit more as we go into the session. Table spaces are file groups. PGA temp table space is kind of more like the temp database, and redo logs undo is the same as transaction logs. We write our undo in multiple places, and our redo has to keep track of that so it can redo if we need to roll things forward, as well as roll things back in the undo. So then we get into more terms that you need to know. RAC, Real Application Clusters. This is the hardware clustering solution with software clustering that's offered from Oracle. You will hear that many people just worship this. We'll tell you why we don't recommend it and why it's not really the thing for the cloud. ASM, Automatic Storage Management, instead of using, for those Linux people, LVM, or actual Linux volume manager. There is a volume manager that is specifically for Oracle. There's some little performance gains from it because people can use ASM to add to another disk group, the volume, and it's managed. It takes a management layer outside of the database and puts it inside the database so they can manage it. And then we have our SGAs, which is our system global area. Our PGA, we talked about our process global area. AWR, talk a little bit about that. And then Data Guard. Think of Data Guard as being very similar to always on availability groups. We'll go into that and why that's very important to our architecture design when we get into the cloud. And then RMAN, this is our recovery manager. This is our backup tool. It is the de facto tool that everyone uses for backups, but we're also going to talk about the weight that puts on an Oracle database in the cloud and why we need to evolve when it comes to our backups. So understanding HA versus MAA, maximum availability architecture is something you will hear about from Oracle DBAs all the time. It is a white paper that's available. I've got the link to it down there in the bottom of the slides, and it is known by different things from different vendors in that, but this is the one that Oracle goes to. Thing to know is that rack is just a suggestion in this. It is not a requirement. DataGuard is a requirement for it. And when we start talking about the levels, you've got bronze and so on, silver, gold, platinum, and how it goes up, you're going to change your architecture depending on this. But it was designed for either Oracle Cloud Infrastructure, which is a big focus of it, or it was designed for on-premise. We're talking about Azure, and Azure is going to be different. So when we start talking about high availability, you need to have those discussions. Get everybody in the room, talk about what does it mean to be highly available. You're going to find that rack doesn't actually meet many of those requirements. You say, if a data center goes down, do you need your database to still be up? Well, yes. Rack nodes are all in the same data center. So that's not going to meet that. That's why we fall back to DataGuard. And, then you need to find out, do any of these HA solutions have the support of the vendor? Does it have support of the cloud architecture? All of this. Does it have Oracle support when you're building it out? So these are those questions that you need to have before you ever start building out your architecture on Azure. And I'm going to tell you how we build our architecture in Azure to meet many of these requirements. This is the other issue, rack. Do you really need it? Rack is definitely a solution. It is not the end-all be-all of Oracle. It does introduce a lot of redundancy. Unlike always on availability groups, you're going to have all these different servers, these nodes that are communicating with one database, and they need to keep each of them up to date on what the other is doing. I'm selecting from here, I'm updating from here. I have a lock on this block. I have a lock on this object. All of that needs to be communicated. They all need to know this, and it's called the global cache. These global cache or GC weights you're going to see inside a rack environment. And if the code and the design doesn't work with that, you can see a lot of latency. So this is something that we're going to look at. The more servers you have, of course, more latency you're going to have, and the more demands are going to be on this. Again, it's not true HA, but it has some features in it that DBAs love. And those features have been built into other products that we will then incorporate into our design as we're moving forward into Azure. And that comes where Oracle DataGuard comes in. It is very similar to always on availability groups. You have your primary and your standbys that, of course, you can have as many as you want in secondary availability zones. Start talking about that. AZ, we love that. Separate regions, we can do that. And it has some of those rack-like features. So we can do something called fast start failover. That means that you have a primary, and if that primary goes down with active DataGuard, the secondary will automatically start up and take over as the primary. This means that we have not just our DR, but we also have high availability. We can use this for rolling upgrades and patches, which is another feature from 12c on with DataGuard. We also have the ability to use the ONAS, the Oracle Network Server service, along with the DG broker, and configure all of this and have it fail over the sessions. So for the user, this is completely transparent. It will actually fail over those session level connections as well. So these features are extremely important when you're talking to everyone about how to architect Oracle into Azure, that we can bring in some of the features from Rack that they love without having that overhead, without violating their licensing for Oracle, and to build them out a truly HA and DG or DR environment. So when we're sizing this out, a lot of you may be looking at it because I spend a lot of time in Exadata. That's what I do. I migrate a lot of Exadata workloads. We migrate the workload. You will never hear me say, I'm going to migrate that server. We don't lift and shift servers. We migrate over a workload. And the reason that we do this is, as you're seeing here, the hardware could be old, end of life. It was never sized out appropriately to begin with. It is an engineered system. There's no way to build it in the cloud. These are the reasons to just say, forget the hardware, don't even look at it. Look at the database. What does the database need? The automatic workload repository is our best bet of collecting that. You will hear people that are still using the AWR miner. I've heard this from from Oracle today. They were using it. I'm like, you realize that code hasn't been touched in 6 years. Why are you using? But it still gives us the foundation of data that we need to grab points of information that is good at calculating this. It's always on. It's available with Enterprise Edition if the customer is using Standard Edition, which not very often anymore, but if you see it, there's something called Stats Pack, which is the predecessor to AWR. They can use that. That's absolutely, acceptable, you will get most of the same data points and you can use it the same way. So what does the AWR architecture look like so people from the Microsoft world can understand this a little better? You have your session state objects. They're all in memory. They have their own background memory process. It's called the mmon. And then the ASH uses the mmon Lite, MMNL. You'll see these. If you were to do like a PS minus EF and grep for Oracle, you will see these processes. There's a lot of them for Oracle, unlike 2 for SQL Server on Linux. You'll see tons of them for this. And you'll have mmon and mmon Lite. And these write to the $V views. Now, what's interesting is that while it writes one way, we read the other. And this makes sure that there's no locking. The people that wrote this really did a great job on it. That AWR data, along with 1 out of 10 of every one of the ASH samples, or when the buffer fills up, there's a memory buffer around 3 to 5 megs for this in memory. It will write out to the AWR repository that sits in the sysaux table space. And then this is aggregated down into the DBA hist views. And when you're querying a DBA hist table, know that you are querying tables, and those are historical data, versus $V views, which is memory. That's what you're querying there. So these are kind of a way to understand that, the buffer versus the actual objects, and the aggregated down data. But this is what the AWR architecture looks like. So when we're doing a sizing of the AWR, we ask for a 1-week report. Even though that there's averages in that, we are trying to get a real good look at the report. We're trying to get a snapshot of a good workload. If the customer has, let's say, their workload escalates through the month, I'm going to want an end-of-month report. If they have really big workloads during certain times of the year, that's when I'm going to want a 1-week report. I want to be able to get a good sampling. I ask for 1 report. You'll have people that'll send you, I want 1 week, it's 1-hour reports, and they'll send me 168 1-hour snapshots. I'm going to have them retake that. I want a single report. If you are adding these numbers together, you're asking for trouble. You're asking for mistakes. Don't do it. It's not worth it. DBAs and developers may say that that's not how you do this. This is made for optimization. They're not looking at it from a workload perspective. I do have a blog post down at the bottom that tells you how all of this works, so keep that in mind. I also have another blog post that will tell you I took examples of, peak points, and that's it. They'll say, well, let's look at a peak workload. What does a peak workload mean? Was it peak in CPU? Was it peak in IO? Was it peak in memory? We need to see an overall set of workloads so we can get those numbers. And I'll show you here, we have some numbers in here, some wiggle room that we put in to help kind of bring those up to where they should be across the board. And then if you need assistance trying to find out when the peaks are in the repository, there's a link to a script that'll help you find the top 5 that are in the repository. And the size of the database and all that data in like 10-page report, they never put out the actual size of the database. So you need to actually collect the size of the data files and everything and find out what the actual size of the physical database itself is. So here's those fudge factors, that wiggle room I was talking about. These numbers are used and calculated into the Azure numbers to figure out what we need in Azure. I recommend don't mess with these too much. I mess with them, of course, because I'm working on Exadata. I'm going to bump the numbers up for IO, of course. If they're using a lot of flash cache, of course, I'm going to bump it up for memory because I'm not going to have that available to me. Things like that. If my SGA has been shrunk down to make it offload more, things that I need to be concerned with. But I usually leave them as they are for a standard Oracle workload. And these numbers are then utilized with the AWR points, and it outputs something like this. And of course, that blog post will go in deep into this. We don't have time for that. It is a 2-hour session all by itself. But you can see the output of it is that it will take even rack databases down to a single instance, tell you the percentage of time that it's actually using. Those last 2, if you notice, they've got like 819%, 266%. Those are rack databases. We brought them down to a single instance. So understand that. It'll tell you the amount of RAM that's required, VRAM, virtual machines, how much IOPs, how much megabytes per second it's going to produce, and then the amount of vCPU. And then you can size that out. You can then go pick your VMs and know that you're going to pick ones that will meet your workloads. The averages on this is what was in the workload. The peaks are those fudge factors, those wiggle room that's been added inside this to adjust for any averages, to adjust for any peaks that may not have been collected as part of your workload. So these numbers are safe numbers to say, if I size for this, I'm going to get performance for Oracle on Azure. Are there any questions so far?
No, there aren't. Thank you.
They're all overwhelmed and going, oh, it's too much data. I understand. So the next one, after you heard it was all about the workload, is it's all about the hardware too. There's a real challenge that we have when we start talking about infrastructure as a service. The infrastructure guys are like going, yeah, I know the hardware, but I don't know anything about databases. Database folks from data and AI, they're like, I know everything about SQL Server and Azure SQL, machine learning and AI. You want me to know Oracle too? So Oracle databases kind of fall into this really like well in the middle, and it can be really challenging. So knowing the data that I'm about to tell you now will really make a difference in how to design a database properly, and especially from the physical standpoint of getting a VM once you know what your workload is. AWR already knows what you need. Now you need to make sure that you have the hardware to support that. So for infrastructure as a service, there are limits on the VMs. Even if you look at the limits at that storage or at the VM level, understand that nobody wants to be the noisy neighbor, and Azure makes sure you can't. And those limits are called IO throttling. You'll see that especially with Oracle, that there is throttling guaranteed to make sure that you don't take more than it can handle. So read up on that VM series documentation on your storage. Know the difference between storage limits, VM limits. Find out about bursting and read-only caching. These are things that are extremely crucial to any infrastructure as a service DBA. It doesn't matter if you're putting SQL Server on infrastructure as a service, MySQL, Oracle. These are things you must absolutely know. Understand your series. I know it looks really good and cheap to do an A or a B series VM. Yeah, you shouldn't be putting a database on it. D series, maybe. L and H, they're just not made for Oracle workloads. Not for Oracle workloads or RDBMS. We mostly use E and M series, and even then there's certain ones that you want to look for. So E series might work for some of your average workloads. I spend most of my time in the M series. I have no choice. Again, I'm working on like Exadatas and very large databases. These are your memory optimized ones. E series falls into that as well. And I've got a link down here so that you can look into those if you're curious about learning about them. Understand that we have up to 416 vCPU, 12 terabytes of memory. These are not small machines. This is how I scale vertically. If I can't scale across with rack, I'm scaling vertically with these VMs. That with Active Data Guard, I can deploy a secondary read-only for those data warehouse loads, and I can disperse the workload with the read-only parts to secondaries and have them read-only and have them available. And again, that takes some of the pressure off that primary. We have huge IOPs. Again, this is all dependent upon the combination and how you scale up in it too, because scaling up a VM will also allow you more IOPs. The limits, of course, will expand on this. You pay more money, you better get more for it, and that's what you're getting. There's also InfiniBand. Most people don't realize our network, the way that it's built, we do have InfiniBand behind the scenes. So definitely look per VM. There's different series that have really great network behind it that can support your workloads that you're dealing with. Also, for those that say, I've got a whole bunch of small databases and I don't want to be putting them on a ton of VMs, we have what's called constrained VMs. They are out there, they're easy to find. The pricing calculator is a little weird on them. I do have the link to this. Keep in mind that when you're seeing these in the pricing calculator, they're misidentified for the amount of vCPU they have. Even though they say, like this first one you see, standard M8-2 MS, vCPU is 2. That's what you can divide them by. It's actually an 8 vCPU machine that can be divided by 2 vCPU each. In other words, you could put 4 databases at 2 vCPU each. The pricing calculator may be a little confusing on that. So keep that in mind. Same thing as you go down, the one that says M32 8 MS, that one's going to be 32 vCPU calculated by 8 each that you could divide them up by. So like I said, it's a little confusing. And the specs, even though they're listed here, what they're the same as, they are now in the pricing calculator. You can look them up directly. Before they weren't when I actually wrote out these slides. The other thing is to keep in mind, letters mean something. When you see that S is telling you that you can use premium disk with it. We like the S's because for databases, we pretty much always need premium SSD. We are not going to be using standard hard drives. We are not even going to be using standard solid state disk. We're going to want premium solid state disk for most of our databases. So by choosing one that has an S in the name, that means that you can use premium. Okay. When you see the V3, we have a tendency to kind of stay away from the V3s. We go for the V4s. They have a better chipset on them. These are the things that you want to start to know as you start to work within the virtual machines. And I have further blog posts on this that tells you information about it that are in the references in the slides at the very end. The next is storage, and storage is completely separate from this because you will find most of your databases, what it needs in IO doesn't mean that it needs a lot in memory or CPU or vice versa. So CPU and memory is put together, your storage is separate. You know, on average, Oracle has shown that it needs a lot more. The only one that has this challenge is probably SAP HANA or SAP on Oracle. Those ones are high IO machines. They're going to require it, and we need to be very specific, and we're actually looking at the storage requirements that you saw in that actual sizing. You need to know what your storage is being used for. So if it's used for backups, it's not a big deal. You know, if you've got a window that your backups can go for 8 hours, you could probably use blob storage for it. It's a small database. It's like 200 gigs, no problem. You're good. But that's not where you're going to want to put your data files. And we need to be aware of that we need IO that can be handled by our disk. Know the difference between these storage accounts. When we start talking about GPv1, GPv2, these regular storage, that may be for flat files, but it's not for our database. Block storage may be for our backups, again, not for our data files. File storage, premium file storage, we will use for faster backups, again, not for our data files. What we will use is premium solid state disk, ultra disk, if it meets. There's certain requirements behind that, and Azure NetApp files, and I use that very, very often for my Exadata workloads, those high workloads that need ridiculous amounts of IO performance. So those of you that are out there going, I have an Exadata I need to migrate over, it can't be handled by Azure. Azure NetApp files is your actual key to that. Also understand redundancy. Depending on what the redundancy has been set up for your disk, what you choose, this is your high availability as well. Along with availability sets, you can set this up to have copies of your disks in multiple places. You can have it copied naturally 3 times inside your availability zone. You can have it set up in multiple availability zones and have it in a secondary region like ZRS. Geo-redundant storage where it's actually set up in another geo region, and then geo-zone redundant storage, which is just all over the place. So I've actually documented this out here. So if you're curious how these work and what they actually contain, this is how you set this up. This is how you ensure that you have the copies you need, because as a DBA, we know we're only as good as our last recovery. We know we need to be able to get our managed disk back. And that's where all of this kind of comes together. Notice that you have all these different storage accounts. This is for our backups now. Keep that in mind, that we've got our backups, the kind of storage that it's on, the support tiers. Okay, remember I was telling you that for many of my backups, I would use the file storage, premium, and I might set that up for ZRS to meet my RPO and RTO for backups. These are those things that you have to talk about as you start going forward. Backups and RPO, RTO conversations are usually the last thing that we have. It's after we've architected everything else out, and now we're onto this and deciding, do you want to do snapshots? Do you want to do RMAN? Do you want to do backups? How long do you want that backup recovery? Do we need to have the same storage we had on premise, because we're now able to do snapshots and we've got a data guard, secondary, and all these other things they may not have been able to do on premise. So keep that in mind. These all fold in together as we're building out our Oracle environment. Next is understanding our disks. So this is premium solid state disk host caching. I want you to understand host caching versus bursting. Now, you will hear bursting has great performance. For premium solid state disk, you will have these numbers, P1, P2, on to P20. Only those P1 through P20 disks, which are small, look at them, they go 4 gigs to 512 gigs, you can get something called bursting. Now, bursting works on accumulation. That means that if you have an even workload that's running right there at that 3,500 IOPs, you're not going to be accumulating anything that you can utilize later. It's all on credit. So you need to be able to be down here. Let's say you're doing 1,000 IOPs all the way through the day. You're getting to get that credit for all that IOPs that you're not using. At the end of the night, you have a batch load that comes in and you can burst up to 30 minutes and get up to 3,500 IOPs and get all of that extra. So keep that in mind. These are kind of how these work. You can get up to 170 megs per second instead of 25 megs per second. But you have to actually utilize those credits. You have to collect those credits. So these would be workloads with different degrees of IOPs and megs per second that it's using. It has to build up a credit that it can use later on at night. If you need very even performance and your workload is very, consistent, bursting probably isn't going to do you much good. And that's when we get into those P30 through the P50s. P30 through P50s are a common disk that we use with Oracle on Azure. It provides us with really good performance. Keep in mind that you're looking then at cached performance as well. The reason that we like read-only cache is that we're able to get better performance by caching those reads. We don't never do read-write, and I'll go into that a little bit more here later. But we want to get better IOPs. And that's where you're seeing the IOPs per disk. You can see with the P50, we can get up to 7,500. Now that P50, we're going to use 4,095 gigs. And I will go over that here in a second and why. The reason that we would go up to the P60, P70, P80 is that we want larger disks, but keep in mind with these larger disks, notice that final copy or that final column where it says how much we can cache. That's our challenge. If we go over 4,095, the read-only caching disappears. It'll shut off. So if we allocate more than 4,095, we would lose that. So we can get higher IOPs, but we would lose our read-only caching. Do you actually need it as you start to go higher? You may not. Again, this is something that you're going to look at for your IOPs, for your system. What does your database require that makes you decide what disk you're going to use? Are there any questions on that area there?
No, there aren't. Thank you.
They're good. Next option for storage is UltraDisk. Now, UltraDisk has some pretty good numbers when you start looking at the IOPS range of 160,000. It only supports the uncached reads. You're not going to have any caching or anything like that. It doesn't support disk snapshots. You'd need to use a third-party technology for that, but it's there's no integration with the Azure backup or the Azure Site Recovery too. So you would need to use a third-party backup for it to actually work with that backup. They give you 16 terabytes of per region for the subscription. You can contact support and they will up that amount. So you can get more, but it has to be actually set up by Microsoft. And it isn't available in all regions. So this is something you absolutely have to look at and make sure it's also available for the VM that you pick, because it's only certain VMs that you can get to UltraDisk. And last but not least, Azure NetApp files. Azure NetApp files is definitely what I use for my Exadata workloads. This is able to get me up to 320 IOPS. So yeah, all of you that are going, you can't handle my Oracle workload. Yes, I can. This bypasses any of the VM per VM limits on the throttling. We don't have to worry about that. We're only limited by the NIC, and I'm able to create multiple capacity pools. The other nice thing about capacity pools is that they're more like storage arrays. So you can assign these to more than one VM. More than one VM can actually allocate it as disk. For those systems that, let's say, they're, e-business suite, I can put the application tier, the concurrent manager, the database tier, all against this storage, do a snapshot of it, and clone it in a matter of minutes. These have a lot of features that are really powerful that you may not have had before. To create dev and test instances in just a matter of minutes is a keen feature that especially e-business suite DBAs love, absolutely love. Any multi-tier system, it makes a big difference. We also can create, instead of having a data guard instance, we call it the poor man's data guard. We will create a snapshot and have a snapshot every 10 minutes going out there. And if this main system goes down, they just bring the snapshot up in a couple minutes, they're back up and running. So keep that in mind. There's a lot of other features in this just being storage. So for our environment, especially for Exadata, this is absolutely crucial for us to bring these workloads over into Azure and give them the performance that they need. And this is our discussion about IO throttling. We see this all the time. We have internal tools at Microsoft to allow us to view this. We will see the IO throttling. If it happens, the first thing that you'll be told is that you need to up your VM. Go to the next higher VM. Get more IO that way. But it really is a combination of disk, IO, and workload. Many times you'll find out with our Oracle databases that you may have, the space advisor running every night. If you're not looking at that report, which most people aren't, just shut the job off. It produces a lot of IO. There's no reason for it to be on. Shut it off, go forward, save that IO, and you may stop IO throttling, because all it takes is one job to throw you over the threshold and everything actually throttles. So that's really a concern. Your RMAN backups, if you can move away from RMAN backups again, that might take your IO down, let your batch loads get through. So it is extremely crucial to know what's happening in your database at a given time to make sure that performance is good. When you're getting support on that VM, those folks may not understand the database workload. So knowing both is important. So bring in additional support. When you have these IO issues, when you have IO throttling, consider Azure NetApp files when you're having to get more IO. Think about striping. Old-fashioned striping of multiple disks, or maybe some bursting, shutting off those unnecessary jobs. All of this will help you with your performance. As we stated, offload those backups, get away from them, refactor batch processes so they're more efficient. How you've done things on-premise may not be the way that you want to do it in the cloud. So it's something that you need to consider. As that customer we were talking about that has 7 terabytes of daily data that must be loaded, we are refactoring it right now. It looks like it's going to go down to 20 gigs. 7 terabytes down to 20 gigs, big difference. And they found out that it was easier when they were on premise just to do a CTAS, create table as selection, grab everything over. When they get to the cloud, it didn't make sense. There was a lot more distance, network weights, everything else. It made a lot more sense to find what data they actually needed and build their data loads off of that. And the data went down extensively. I mean, that was a big deal for them. And then our cache settings. There are a lot of cache settings that you will see, blob cache, all these others. Read cache we use for our databases. We do not use read write. For your databases, you do not want writes cached. It can actually corrupt your database. You want data to write through to those data files. Read caching does have a benefit and does make a big difference. Past our P40, of course, we have disks that are over 4,095 gigs. When you have that happen and you've turned read caching on, you think you're good. If you allocate over 4,095 gigs, the read caching will shut back off. Okay, so you may think you configured it and it didn't. So keep that in mind that 4,095 is that threshold that you can turn this on. Larger disks, you have the choice. You can just shut it off and use all that space, or keep the 4,095 and get the higher IOPs outside of read caching. It's something to keep in mind. Smaller disks, we have them striping and mirroring smaller disks and using bursting. So again, it goes on your workload. If it is a consistent workload, that may not be an option for you. And these are available on M series and other VMs. You just need to be aware, is it an option for it? And you will see that if you look up the VM, it will tell you what options are available for it. So don't assume, go and look it up and make sure you don't end up getting hit, because deploying a VM and then finding out that you have to move it to a different VM, that's kind of a pain. So take the time to do your research first. So next one, any questions in that area there?
Yes, we have 2. First one, are there any commands to know what storage setup we have in Azure?
Storage sector, yes. I need to blog about that. That's a good one. Absolutely. And I don't have them off the top of my head, but I'll get you the answer afterwards. How's that sound? There are Linux commands that will get all that information for you. So I'll get that out there. So get his name, I'll get him the information.
Name is Cole. Okay, the next question. Do block sizes affect any of this?
It does. That's something else I need to blog on. We have a lot of people who are still using like 16K block size. Much of that, I guess it's a myth, has been brought down. There's very few use cases where you need like a 16K block size for your database. You should be using 8K. And I'm assuming that they're talking about the block size for the database, the Oracle database.
Yes, it is.
Okay, yes, use 8K. That has already been, that myth was debunked back about 11G time, but it was a 10G one that we were using different block sizes. I haven't seen a database yet that's actually put it to truth. They'll say, I have to have 16K, and you find out, no, the 8K works a lot better, and it works much better within the network confines of Azure.
Okay, one more question. Are data ingress and egress costs part of the story here?
It is, especially I was talking about that customer with all that data that they need to data load every day. Going across all these networks can really make a difference. When you're going into Azure, there's no charge. You can load as much data as you want, but if you're bringing data back down, it's really important to identify what that data is and how much you're loading back and forth. So yes, you will have egress charges if you do that. Okay, ingress, they're glad to let you load as much as you want in Azure.
Thank you.
Quite welcome. Thank you for the questions. So failures due to backups. Modernize the way that you're backing up databases. RMAN, like I said, is a streaming technology. It can be really slow. I had one customer that we had done everything right. It was a brand new product in Azure. The goal is to automate everything, 300 new databases every single year. It was a beautiful project, but the database administrator who was allocated to test the backups hadn't done that, and found out that instead of 20 minutes, it was taking 15 hours to go to blob storage. It was not a solution that they could do. Problem is they had already priced out the product to sell to other people. And so they were kind of between a rock and a hard place. For us, Commvault ended up being the solution that won that day. They were able to provide them snapshot technology at a price that was excellent, and they now do snapshots of those databases. Commvault provided them with both the snapshots, RMAN backups, as well as data refreshes, so they can do object level refreshes. And they would end up doing a snapshot, recover the snapshot, grab the object out, and then restore it, instead of doing exports and imports all the time. Data pump. Data pump is very slow too. These are high IO demand items that you just don't want to introduce your database. So keep that in mind. And AWR will show this. Ash will show this. You'll see RMAN as being the top consumer of IO. Your weights are there. So, look at those. If you see that, remove that weight. Evolve your backups. Go to a snapshot technology. There's many of them out there. ANF has one, Azure NetApp Files. You've got Commvault, which I like just because they've done a good job with Oracle and Azure. So they get my vote there. Veeam is there. And Azure Backup right now is in a private preview for a snapshot capable for Oracle. They won't have RMAN capability built into it, but you can also use RMAN if you need to stick to RMAN. We recommend either using premium file storage or to use the new NFS that's coming out pretty soon. It's not GA yet, but the NFS storage soon will be a good choice as well. So let's talk about Azure Cloud Shell. I think as we use our tools, many people think they're going to go to Azure and they're going to have to use all PowerShell. I haven't written a PowerShell script yet. All my stuff is in Bash, and I do it all from the Azure Cloud Shell. Azure Cloud Shell, you can add storage to it, and it becomes my jump box. And I'm going to use it for my demo here in a minute, so you guys can actually see that. But I'll create a database out of there. I have all my scripts out there. I connect to each one of my VMs, and you can see it even when you're in the portal. You can see that little square that I've got there that I've circled. It's that's your link to it, and it has the choice of either Bash or PowerShell. You can see I've got mine set to Bash. Also simplifying your lift and shift. Use your Oracle Enterprise Manager. It comes with a limited Enterprise Edition license. deploy that out there. Do not use one on-prem. It's very chatty, and talk about egress charges, or you're going to see them from that. You know, Enterprise Manager has to communicate. It has to get all of this data from the target. So you want to put one up in the cloud. The VM is very inexpensive if you need a document for how to install that. I know we haven't published it out to the Microsoft Docs yet, but I do have it written and I'm glad to share it. And you can set this up so that with the lifecycle management pack, so that you can automate patching of your Oracle databases, automate management templates, scan for IP addresses, and as soon as a new server comes into play, automatically add it to your Enterprise Manager. You can use the brand new automated Linux patching for your VMs, and that's a service from Azure, and have it patch your VMs too. So from the Linux, the OS side. So you don't have to do any of this. So keep that in mind, that there's ways of what we call simulating PaaS in an infrastructure as a service. No, it isn't PaaS, but it will automate all of this. So these are things that I do a lot with my customers and make life a lot easier for them when they say, I need to be able to do a lot more with less. I don't have the DBAs to do this, or I want my DBAs to do other things. I'm all for this because I get bored easy. So I like automating all of this. So keep this in mind, and glad to help. And I know my blog, DBA Kevlar, has a lot of this stuff built into it from years doing Oracle Enterprise Manager. Migrations, it's not just about this infrastructure. Know your workloads. Take the time. The first thing that they're going to do if you call in support is tell you again, scale up that VM, get faster disk. Really look at your AWR. When I'm troubleshooting a problem, a ticket's been handed over to me, I get the AWR for that time and work with the support people, or do it myself and find out what's going on in the VM, and then look at the workload. Many times you will find out that if you just fix the stats, you optimize that workload, you're going to get an 85% improvement. You throw a better VM at it, better storage, it's only going to fix it temporarily. And it's only going to fix it until the database grows some more. Fix it right. Don't fix it twice. Tools for actually doing this. Migrating. RMAN is still the best. Golden Gate, only bring Golden Gate in if you've got somebody who actually knows it, and that's for synchronization, not so much migration. Some people are using it that way. Again, knowing those trail files and being able to support it. I supported it for a while, and I still don't recommend it to people. You know, you've got to have that knowledge in-house to be able to troubleshoot it. It's easy to install, it's hard to support. The tenant licensing is pretty expensive too, but you can use an RMAN duplicate and then create a data guard environment and actually have your secondary up in the cloud and then flip it over when you're ready. Azure Data Factory really works well when you're trying to synchronize all of this data. You can use that if you need to. And then modern tools, you've got, you know, Azure NetApp Files has a solution for migrating to the cloud, as does Veeam. And Azure Migration Services does have a way to actually migrate VMs up as well. VMware has one as well. So you're already on VMs and you just need to bring it to an Azure Hyper-V VM. You can do that. So keep this in mind, that depending on what you've got now, there's a lot of different tools you might be able to use to ease your lift and shift. Third-party tools that also, when we start talking about the data loads, Data Pump is there, probably not going to recommend it. PL/SQL, that's a lot of work. Same thing with Change Data Capture and Golden Gate, but some of these other ones might make it easier. The Azure Data Factory is easy to set up and connect to Oracle. SQL Data Examiner, DB Forge Data Compare, and the SQL Delta Duo. These are tools that get really good reviews and have been used by a lot of my customers to migrate up to another database. So if you want to just take parts of your data, and you also have like transportable table spaces, if they're already sectioned off by table space, you could grab it that way as well. There's a lot of different ways to slice and dice this and migrate it up. So how do my folks build their Oracle environment? They usually grab a base image, and the link down here will tell you how to get to the Linux images because you won't see them in the portal. And then how to create your own images. So what they do is, let's say they want Oracle Linux. So they'll grab an Oracle Linux. Don't grab the like marketplace images for Oracle. Those are made to kick the tires. They're not made for an enterprise environment. So grab your Oracle Linux image, grab your Red Hat. Those are the two OSs I recommend. Those have the support inside Azure. You can do Windows, but I usually recommend not for Oracle. And it's not about Windows, it's about Oracle. When I was there, to get a Windows server for development, almost impossible. And if you're not developing for Windows, you're not developing for Windows. Let's just put it that way. But you build out your Oracle installation, get your ASM kind of set up and installed and all that, create your base images off of it, and then deploy. And that second link on this slide tells you how to create your own images. So you have your own image library. And then you can just use it over and over again and deploy your databases out to it. So create once, use over and over again, create your own images. Don't be worried that they don't have the exact image in the portal for you in the marketplace. And what does this architecture look like? I know we're running out of time here, so I'm going to try to go through this pretty fast. This is an architecture design for a standard workload. There are 6 different levels of architecture that we use just standard. This is saying, we're going to use standard solid state disk. This is for a small workload. We've got our application server, and we may use blob storage. We always try to use a standby database, and we always use Oracle Enterprise Manager to manage it all. This is kind of those designs that we use. If a customer wants to use ASM, they can, or if they want to just use Linux and have this in there, no problem. And we use a primary and a secondary availability zone, and we can fail over those sessions still. It takes a manual failover for the database, but you can see that all of this is here, and we use RMAN to back it up, but this is for a small database. When we get into that level 6+, this has really changed. We're still doing our failovers and that. But you'll notice that we're using Azure NetApp files, which is outside of the availability zones. It's regional. And this is for fast performance. And we put everything on it. Our Oracle Enterprise Manager is stored there. Our application tier is on there. Our database tier is on there. And everything goes to this ANF to give high performance. We may be doing snapshots to actually get our database recovered. All of that is still designed in a way, but you understand that you've got very fast performance on this, and these are high level M series machines, and we're getting really good performance out of this. This thing screams. And the same thing goes for how we distribute data files. So level 1, you're going to end up with all your data files in one disk, and you're not worried about performance. You've got recaching turned on, and you're going to bring your backups to blob storage. As you escalate up, as you evolve, I should say, your data loads, and they get more demanding, we're going to start breaking this up. You're going to see that we've turned on our read-only caching, and we've broken this up, and we've moved our control files and our redo logs and our archive logs out. We've tried to get better performance that way. Then we're striping onto disks. We're striping disks to get better performance, and our backups have gone to premium disk storage. We've separated out our archive logs and put those on separate disks. Then when we get into ANF, of course, we've put this all onto a data pool because our ANF can handle it all. We don't have to separate it anymore, but we're doing snapshots now. And again, we've separated it all out logically, but physically it's sitting on an ANF data or capacity pool to give us this great performance. Any questions on any of that?
Yes, we have one. Do you see any performance difference between RMAN hard drive versus RMAN tape backups that eat up resources for the VM?
Oh, yes. Oh, yes. RMAN, like I said, is a concern. Anytime you're utilizing it as a streaming technology, if you're to stream it to tape, you're going to have very, very slow performance. If you need to age out your backups and you're not concerned about them being readily available, I would back them up first to a premium disk and then age them out to blob storage, to colder storage. I would not try to use tape.
Okay, that's all we have. Thank you.
You're welcome. So I use this slide just because it's got my face on it. No, this demo here is to try to give you an idea of what it looks like when we're doing a deployment and how easy it can be. Where can you find these images? There are, like I said, tons of Oracle images out there. There are 18C, 19C images out on the marketplace. I don't recommend using them. Again, they're for kicking the tires. They're not for using in an enterprise level database. All licensing is bring your own license. I recommend highly finding the person that knows licensing inside and out, will fight for your rights. I think licensing is much harder than actually migrating the database. So get them in front of Oracle and fight for your rights. Don't let it go bad. Don't let it go sideways. Get them in there and saying, you know, this is what we need for licensing. The nice thing about me sizing out the workload is that most people find that it isn't the 2-for-1 licensing cost that Oracle likes to tell you. I'm only licensed for what you need now, not what you need 5 years from now or 10 years from now for what you would size out your hardware on-prem. So they end up saving money. So keep that in mind too. And how do we do this? So I'm going to show you. I've got my and I probably got, did it knock me out of my window? Look at that. There we go. Yay. So we can see our Azure Cloud Shell, and I'm sure I got knocked out of here. We're going to reconnect there. And this is the Azure Cloud Shell that I was talking about. You can see that I am in here with Bash, and you can connect to the Azure Cloud Shell outside, if I can get this to go away, outside of the portal. And that's what I've done here. You can see I've got my cloud storage that has all my files. And I am going to go to, sitting here right now. Yes, okay. And we're going to grab this first command here just to save us some time and look at these so you can see the actual list here. Has to think about this for a minute. And this is grabbing from the catalog versus the portal. You're going to find there's a lot more stuff behind the scenes than you will see in just the portal itself. And there they all are. I'm not sure why it complained about that, but we also have these. This is all the, but these are all the Oracle images. Oh, it's so slow right now. No, I didn't say enter. Give me this instead, since it doesn't like the other one. There we go. That looks much better, much better. This is for the Oracle database. You can see there's versions 12.1 through 18.3. There was a 19C. There it is, up at the very top. They've named it differently. So these are the actual Oracle database versions. And we are going to deploy an 18C standard edition that said SE versus EE. We could do EE too if we wanted to. And to do that, we're going to use a script that I have here. Again, make life easy. If I can remember which screen I'm in. And you'll see that's right there. Or a VM.sh. And we're going to name it Summit Group today. A resource group. It's going to go grab, what do we want? I think we're going to grab the 18C one, I think we decided. And then I'm going to name it Aura 18.3 SE1. Database size, we're going to do standard solid state disk with LRS on the redundancy. So remember what we talked about in our presentation. And then I am going to create a user in here. It'll also set up keys too as part of this. And we're going to deploy this in East US. and it starts to push this out. So this is going to start deploying. And if we go back here, because my share screen keeps getting in the way. We should see our new group. Thank you. Always picks the best time for that stuff. There's our summit group that it created. And then we will see the resources that it starts to deploy. There we go, all of this. So you can see our VM is already starting to deploy. It's already got us all our network, our virtual network. Everything is configured there. So this should be almost done. That's how fast this is to deploy. And we'll go into here because we'll be able to see the IP address that's been allocated and everything. Were there any questions while this is finishing up?
There weren't.
There's none, I'm sorry. No, okay. But you can see it verifies everything, make sure that it's running and all good. It'll check everything. And it's almost finished. But this is how most of my customers deploy. Some of them will have the database administrators write out bash scripts for everything, and then they'll punch it into either Terraform or Ansible, or they'll convert it into Ansible. You know, they'll create those images, and once you create the images, you can even pull it from not just images, but you can also have your templates. So all of that is available. And there we go. So if we go SSH, and you can see this, the keys have all been generated and everything for this. Paste. And there we are. I am here, 01. And you'll see, there's my app. So all my software is installed and it is ready for me to set up a database. That's how easy it was to get my Oracle VM. And you could automate your actual database deployments, everything from here, not just the VM deployments. Any questions about that?
No.
They're all good with that one. I have a link to this slide too, if you're interested in it, or the script, interested in doing that. And with that, I am finished. There's tons of links in here if you're curious about it, because of course I also included like FarSync and information about VM site sizing and bare metal, express route documentation for those of you that are talking about egress charges and ingress and how to connect applications at faster performance, as well as UltraDisk. And then the last one is the Oracle database with Azure NetApp files. That is a white paper that a number of us wrote on performance with Azure NetApp files that I'm glad to share. But it kind of gives you an idea of, you know, what's the best way to build out an Oracle database. And I have tons of blogs. If you go to dbakevlar.com, I've blogged a lot there. And the most recent blog on performance for Oracle physical data file locations and IO consumption, it links first to DBA Kevlar, and then it goes over to the Microsoft Data Architecture blog, which is the rest of it. And you can find all of it there. And with that, I think I am just about done if there's any other questions.
We don't have any, thank you.
Wonderful. Feel free to reach out to me. If not, enjoy the rest of your summit, your PaaS summit, and have a wonderful day.